Hello.
Yes, sir. Good evening, sir.
Yeah, good evening. Okay, so we'll do some questions today. The first two questions are written.
Hmm.
Okay, so try these three questions first.
Okay.
You have around 10 minutes to figure it out. All these problems are based on the concepts we have learned in the first three classes.
Hmm.
So far, there have been how many classes for number three? Two only, right?
Sir.
Three, right? Yeah, I don't remember how many classes have happened. Try it out. I'll be back in 5 minutes. Try the questions. First one is done.
No, sir.
Yes, sir.
कैसे बताओ?
Sir, we can apply Fermat's theorem for any prime p, a to the power p congruent to
No, we are
a
not
mod
going to.
p.
We are not going to use Fermat's theorem because we have not discussed it yet. We have to prove it using whatever we have discussed. Try to prove it with the knowledge that we have already had. Use congruences to figure it out.
Sir, with formats, how can it be done?
We are not doing that. Have we discussed Fermat's theorem right now?
No, sir.
Uh,
Uh,
if you think of x modulo 5,
Hmm.
you have what options? 0, 1, 2, 3, 4. If you think of x square mod 5, what will happen?
Okay, sir.
0 will remain 0, 1 will remain 1, 2 will become 2 square, 4 mod 5, right?
Hmm.
So 4 mod 5 technically, okay, we can write it. 3 square is again 4 mod 5, and 4 square is again 1 mod 5, right?
Hmm.
So technically 4 mod 5, if you think of, and 1 mod 5, they are similar. You can think of this as a minus 1 mod 5.
Hmm.
So basically you are getting either a plus or minus 1 mod 5 or a 0 mod 5
Hmm.
for x square.
Hmm.
The 0 mod 5 happens only if x is divisible by 5. That case is anyway done.
Hmm.
If x is divisible by 5, obviously this will be divisible by 5. So we don't care about that case. So
Hmm.
for any other case, we have x square is congruent to plus or minus 1 mod 5.
Hmm.
So x power 4 will be congruent to 1 mod 5.
Hmm.
So x power 5 will be congruent to what? X mod 5.
Sorry.
That is Fermat's theorem.
Hmm.
So x power 5 will be x mod 5. So x plus 4x will be 5x, which will be what? Which will be divisible by 5.
Hmm.
This part is becoming x mod 5. And we have add that to 4x mod 5. Becomes a 5x mod 5, which is obviously divisible by 5.
Hmm.
Is it clear to everyone what we are doing? We look at the divisibility
Yes,
by
sir.
5 and we look at the possible modulos x square, then we look at x square comes as 1 or 4. It will be easier if you think of 4 mod 5 as minus 1 mod 5. So we are getting x square as plus or minus 1 mod 5. And then after that, it is obvious. Okay, try the second one now.
The second one is Samvani like what the question is saying.
It's written in English only. You should be able to understand it. Read the sentence. Any positive integer has a multiple whose decimal representation contains this sequence. Decimal representation of a positive integer, you don't know what it means.
इंटीजर का डेसिमल तो जीरो ही होता है ना लाइक -1.00 या
तुमको डेसिमल रिप्रेजेंटेशन ही मतलब नहीं पता है.
नहीं
डेसिमल वर्सेस बाइनरी पता है मतलब.
नहीं.
Sir, base 10 decimal or base 2 binary.
Yeah. Decimal representation means how you normally write numbers in base 10. Doesn't mean that you have to put a decimal point.
Hmm.
ये सब बेसिक चीजें क्यों नहीं आती है तुमको? Decimal representation means 20. This is a decimal representation because it's a base 10 representation. Decimal, the word means 10. Binary means 2. If somebody says hexadecimal representation means base 16.
हाँ. तो ये बेस क्या होता है इसमें?
बेस तुमको नहीं पता है?
नहीं
Number
सर.
base.
नो सर.
When we are using base 10, all the normal numbers that you have seen so far, the digits that we use are 0, 1, 2 till 9 to make our numbers. When we are writing a number in using these digits, 832, that basically means that it is 8 into 10 square plus 3 into 10 power 1 plus 2 into 10 power 0. Why is 10 so special that we have written the number like this?
Hmm.
What is so special about 10? Why did we decide to make our numbers like this? 832 should mean this. 800 plus 30 plus 2. And 243 should mean 2 into 10 square plus 4 into 10 power 1 plus 3 into 10 power 0. Why have we decided to make our numbers like this? What is so special about 10? Anybody can answer. What is so special about 10?
The base is 10 here.
क्या?
Base is 10.
हाँ,
Base
but
of this number is 10.
why did we choose 10 as the base? What is so special about the number 10?
Aesthetic, like it is easier to add or divide.
No, it's not aesthetics.
Sure.
Sir, it's a simple number. It gives a simple number. If the base was 16 or 2 or something, then the number would have been
If
complicated.
the base is 2, the numbers are very simple. It only has 1, 0,
Sir,
1, 1, 2.
finding like if the base is 10, we can write any number easily. Like 243, the remainders will come easily, so we can write.
No, that is not
like
a
that.
reason. Numbers can come easily, like computers recognize only numbers in binary. This is also easy only. In a computer, all the time you're using base 2.
Hmm.
Why are we using computers में base 2 and normally in life we are using base 10?
कंप्यूटर्स में स्विचेस होते हैं ना, लाइक ट्रू और फॉल्स वाले लॉजिकल गेट्स. तो दो पॉसिबिलिटीज होती हैं एक समय पे, ट्रू और फॉल्स. तो हमने इसके लिए बेस 2 यूज किया है.
That is the reason. Computers are built from transistors and small electrical circuits where on off is the state, either on or off. So there are two options, so it is better to use base 2. But why are we using base 10 in all our lives? We are using base 10 because we have 10 fingers.
इसी की वजह से हमने यूज कर रहे हैं बेस 10.
When humans learned to count, they could count till 10 easily because they have 10 fingers.
Okay.
Historically, we learned to count in 10 because that's how we have evolved. If we had 8 fingers, we would be using base 8. We don't need maths to count till 10. We need just fingers.
Okay.
The natural way to count for us is count till 10. The natural way to count for a spider will be different. That's why base 10 is being used. But how come you didn't know about base number base? Right? I don't understand. How can you not know that? There are many different types of bases that can be used. Base 12, base 8, base 16. All of these are used in certain contexts. If you are using base 8, the digits available to you are 0 to 7. Any number in base 8 will be written as a into 8 square plus b into 8 power 1 plus c into 8 power 0. Any number in base 2 will use only digits 0 and 1. There is nothing special about 10 other than the fact that we had 10 fingers, so we were used to counting till 10. The question is, prove that any positive integer has a multiple whose decimal representation will always contain this sequence. You will always be able to find this sequence in some multiple of any positive integer. Basically, you can say let n be a positive integer and we choose k such that 10 power k is greater than n. Basically, you are choosing a k value such that 10 power k is bigger than n. Now, consider the numbers 2021, 2022 into 10 power k plus 1. Similarly, 2021, 2022 into 10 power k plus 2. And 2021, 2022 into 10 power k plus n. These are n numbers that I'm talking about right now, right? This is the first number, this is the second number, this is the nth number.
तो आपने 10 पावर k ग्रेटर देन n क्यों लिया? इसका लॉजिक क्या था?
You will understand the logic soon. In these n numbers, can we say that there is a number that is a multiple of n?
Yes,
Why?
because it contains all possibilities.
नहीं तो ठीक से बताओ थोड़ा. Because it contains all possibilities is not a good enough reason. In these n numbers, can you guarantee that there is a number that is a multiple of n?
We have all kind of reminders.
When you take all of these numbers modulo n, no matter what happens to this part, that part is common across everyone. There will be n different remainders here, right?
n minus 1 different, yes sir, and different remainders.
So that will cover all the possible residue classes of n, right?
Pigeonhole principle.
So that will mean that there has to be at least one number in this which will be zero mod n.
Zero mod n.
Because the theorem that we had done or the property that we had seen last class, any sequence of n numbers, n consecutive numbers, has at least one divisible by n. You remember we have done this?
Yes sir.
as a number which is divisible by n. So we have just made up what? We have made up a sequence of n numbers. We have made up the sequence in such a way that always this will be present. Each of these numbers will start with 2021, 2022, right?
Yes, sir.
And after that, you have put some zeros. Correct?
Okay. Yeah.
So after that, it is guaranteed that you will have out
I
of any of
remember.
these n numbers, it's guaranteed to have basically a multiple of n. And it
So
is
we choose,
guaranteed to have a sequence of this.
so we chose 10 ki power k is greater than n so that the digits doesn't change. It remains
Yeah.
2021, 2022. Okay.
If you choose a small one, then this will start changing when you add 1, 2 and all.
Yes, sir. Yes, sir.
If you choose a small number, then it is possible that n is so big that when you list out all the numbers, the digit itself gets tampered.
Hmm.
Do you understand what I'm saying?
Yes, sir.
You need to ensure that after this, there should be 0001, and even if n is a big number, it will never touch this part.
Hmm.
You are starting with this, and you are getting a sequence of n numbers with one of them divisible by that. This kind
Hmm.
of a proof is called a constructive proof, where we are getting the required type of thing, constructing it, and showing that it satisfies a property. We are constructing a sequence of numbers which satisfies this property, right?
Okay. Okay. Yes, sir.
Okay, third one. Prove that any positive integer has a multiple of the form this, where there are some ones and then there are some zeros. Any positive integer should have a multiple of this form. Yeah, I won't say anything. Try it out. You have 10 minutes to figure it out. कोई आइडिया आ रहा है इसके बारे में? So let n be a positive integer. And now we'll start thinking of the numbers 1, 1, 1, 1, 1, 1, 1, 1, 1, 1 until k ones. So here k is going for actually k ones, and k can vary from 1 to n plus 1. So basically starting from here up to k becomes n plus 1 here, right? Do you understand what I'm saying?
हाँ.
So there are n plus 1 numbers here, right? And we'll think of all of them modulo n. If you think of all of them modulo n, then there are n plus 1 pigeons and n residue
And holes.
classes.
हाँ.
So two of them will belong to,
Same hole or the same classes.
two of them will have same residue class.
Okay, and yes.
Difference.
हाँ.
Then
And
you
the
take the
difference.
difference of any two of them.
तो कोई जीरो में आएगा ही आएगा एक. मतलब जीरो वंस में ही होगा.
तो मान लो इनका डिफरेंस ले लो, तो क्या आ रहा है? 0, 0, 0, एक 1. अगर इसका और इसका डिफरेंस अगर ले लेंगे तो बहुत सारे वंस, फिर जीरोस. So basically that difference will be divisible by n, right? Because the difference, two of them are in the same residue class, so difference is 0 mod n. So that difference is a number of this form, right? So this is an example of how pigeonhole principle is used creatively. Like nobody would have thought that this is a pigeonhole principle question. But it's so easy once you get the idea.
तो
It
इसको
is,
प्रूफ कंस्ट्रक्शन बोलते हैं जो आप जो कंस्ट्रक्ट कर रहे हैं 1 and 1 1.
this is similar to that, but ultimately it is pigeonhole that's weird.
हाँ, मतलब जो आइडिया था वो कंस्ट्रक्शन का था.
We have taken n plus 1 numbers of the form 1, 1, 1, 1, 1, 1 and so on, and we are saying that two of them belong to the same residue class modulo n. So
जैसे
when you
हमने
take
क्लास 1 में डिविजिबिलिटी का किया था वैसे ही है सर. हमने नेगेटिव सब्ट्रैक्ट किया था.
right, so that is done. Is everyone understanding the solution?
Yes, sir.
बहुत अच्छा था सॉल्यूशन.
Okay. The next one is, if n is equal to 1, 1, 1, k ones, if n, which is this number, is divisible by 7, then n is also divisible by 13. We have to prove that. I can give you a hint. Hint is that 1001 is equal to 7 into 13 into 11.
अच्छा, got it, sir.
So here, first we will use this hint to figure out certain things. Like, for example, you can say this is 1000 plus 1, and this is divisible by 7 and 13, right? So we can say 10 plus 1 is congruent to 0 mod 7, right? And is also 0 mod 13, correct?
हाँ.
Great. So same thing, that whatever we do here will also be applicable for mod 13, by the way. So 10 cube is congruent to minus 1 mod 7, right? So 10 power 6 will be congruent to 1 mod 7. And we can raise this to the power q, where q is some integer, and we can say this will also be 1 mod 7,
6Q, हाँ.
where q is some integer. Similarly, you can also say 10 power 6q is congruent to 1 mod 13.
13, हाँ.
So we have these two facts right now. And now we have to think of the problem where we have numbers like this and it is said that it is divisible by 7.
हाँ.
So let's think about it. N is 1, 1, 1, K ones is divisible by 7. There is an easy way to handle such numbers. The point is that it will be nice if we can convert it to 99999, because that will be 10 power something minus 1, right?
Yes.
So what I will say is, if this is divisible by 7, that implies 9999 K nines is also divisible by 7. because
Okay, 10 cube minus. Hmm. Now we
we have just multiplied by 9 and
9.
9
Yeah.
doesn't affect anything here. So
Hmm.
10 power k minus 1, right,
Is divisible by 7.
is coming as this. So we are getting 10 power k is congruent to 1 mod 7.
Hmm.
So the condition from the problem is equivalent to saying 10 power k
10
is
power 6
congruent to 1
cube.
mod 7,
हाँ, तो
right?
वही 6 क्यू वाला केस आ गया उधर.
No, there we had 10 power 6q is congruent to 1 mod 7
हाँ, तो
earlier.
k इक्वलेंट टू 6 क्यू बोल सकते हैं ना.
हाँ, वी डोंट नो. नो ना, बोल कुछ नहीं सकते हैं. अभी हमको एक रैंडम फैक्ट पता है कि 10 power 6q is congruent to 1 mod 7 and 10 power 6q is also congruent to 1 mod 13. That is just nothing connected to here.
अच्छा, हाँ, सॉरी सर. यस सर.
That is just a random fact we have discovered on 1001 when we check the divisibility. Right?
Hmm.
बट यहाँ पे ये कर सकते हैं ना कि 10 पावर 6 k इज 1 mod 7 रेज करते हैं
What we
6.
can say here is that k is a random integer. We can divide k by 6 by division algorithm.
हम्म.
K is any positive integer. We can always write it as 6q plus r, right?
हम्म.
By Euclid's division lemma.
हम्म.
Correct?
हम्म.
We don't know what r is. R could be 0, 1, 2, 3, 4, 5.
हम्म.
Right?
हम्म.
So we are writing k as 6q plus r, and then we can say that 10 power 6q times 10 power r, right? But when we think of this mod 7, this part is 1 mod 7
हम्म.
because now we are using this fact, right?
हम्म.
Do you understand what I'm saying right now?
हम्म.
So 10 power k will boil down to 10 power
10
r
power
mod 7,
mod 7.
right? Where
Yes sir.
r goes from 0, 1, 2, 3, 4, 5,
हाँ.
correct?
हम्म.
Okay. So now if r is 0 and then k was 6q, in that case it is obvious 1 mod 7,
हम्म.
correct?
हम्म.
So in that case 10 power k is same as 1 mod 7, which is going to be 1 mod 13,
हम्म.
right?
हम्म.
Which means that this number is also 1 mod 13, right? No, this number which is 10 power k minus 1 will be 0 mod 13.
13.
See, 10 power k was 1 mod 13, right?
हम्म.
If r is 0,
हम्म.
do you understand what I'm saying right now?
Yes sir.
So 10 power k minus 1 is 0 mod 13, and we get this number is 0 mod 13. So 13 and 9 are co-prime, so you can divide by 9, right?
हम्म.
And you will prove that this number is divisible by 13 then.
हम्म.
Is it clear what I'm saying?
Yes sir.
Yes,
So
sir.
for r is equal to 0, it works. Now let's think about the other cases. If n is equal, n is divisible, n is also divisible by 13. Okay, so
सर
hmm,
सर ऐसा नहीं है कि जो 10 की पावर k इज इक्वल टू 1 mod 7, इसको हम ऐसे कर दे कि 10 की पावर 6 k इज आल्सो इक्वल टू 1 mod 7. एंड जो हमने पिछले से इंड्यूस किया था कि 10 की पावर 6 q इज 1 mod 7, देन 10 की पावर 6 q इज आल्सो 1 mod 13, फिर k को q से रिप्लेस कर दें. लाइक ऐसा गलत होता है, सही है?
we only have information about k right now. So we know this much. From here, we have to prove mod 13 stuff.
हम्म.
Right now, we don't know. Look, 1 second, let me think.
क्योंकि वो फिर प्रूव हो जाएगा सर वैसे।
If we write k as 6q plus r, we are getting 10 power r is equal to 10 power r into 1 per
नहीं यार
r.
सर, हम अगर k को ही q मान ले उस केस में, जैसे q तो कुछ भी आर्बिट्रेरी इंटीजर था ना, तो इसको 6 की फॉर्म में लिख के, लाइक अगर हम 6 पावर मल्टीप्लाई कर दें होल 6 बोथ साइड, ये जो अपने स्क्वायर में रखा है इक्वेशन, फिर वो उसके इक्विवेलेंट ही हो गया।
We are close to the solution. बस last step मुझे clear नहीं हो रहा है अभी. 1 second. If we write k as 6q plus r, what are we getting from there? We are getting 10 power 6q plus r and 10 power r. Oh, okay, okay. Oh, no, okay, it is clear. We don't have to do anything weird. We are saying 10 power k is coming as this, right?
हाँ
And
सर।
what I'm saying is we can always write k as this.
हम्म
Since we can always write k as this equation implies this, right?
हम्म
So this equation implies that 10 power 6q plus r is congruent to 1 mod 7.
हम्म
Because this is always possible for any integer k, right?
वही बोला था सर, यस सर।
So then everything implies they don't have to do anything else because we get 10 power 6q, 10 power r congruent to 1 mod 7,
107।
and this is anyway 1. So 10 power r is 1 mod 7.
107, यस सर,
And
वही आर इज इनवर्स केस हो गया ना।
once we get 10 power r is 1 mod 7, we are saying that automatically means that 10 power r minus 1 is divisible by 13.
13, हाँ यही कह रहा था सर मैं।
So that number is going to be, we have proved basically that a number of this form is divisible by 13.
हम्म
So what we are using here is, first of all, the information that was given as a hint that if you have 10q plus 1 and that is 0 mod 7 and 0 mod 13, then in both the cases 10 power cube is minus 1 and 10 power 6 is 1 mod 7 and 1 mod 13. And the number that was given, we converted that to 99999 because multiplying by 9 doesn't change divisibility by 7. Even here, once we get 1 mod 7, 9 and 13 are co-prime, so we can remove it, right?
यस सर।
So after that, it works out. Fine. Then one last question on this section. This says let A, B, C be digits in base 10 such that the number ABC, this bar is written on top to show that this is a number where ABC are digits. It's not A into B into C.
हम्म
The number ABC is divisible by 37.
ओके।
Then BCA and CAB are also divisible by 37. We have to prove that those are also divisible by 37. And there is a generalization also possible in this problem, which once you have done the basic proof, you can figure out. By the way, the same hint can be used here also. One second. Was it 7 into 11 into 13?
Yes,
Oh,
sir.
yeah. Okay, then that hint can't be used because 37 is not there. But you should know that 37 into 3 is 111. And therefore, 37 into 3 into 9 will be,
999.
that will be 10 cube minus 1. So you are getting what? 10 cube minus 1 is congruent to 0 mod 37.
10 cube is 1 mod 37.
Hmm. The question has said that this number is divisible by 37. So technically what they have said is 100A plus 10B plus C is congruent to 0 mod 37.
Hmm.
Okay.
Hmm.
So what can we do with that? And later we have to prove about
100B plus 10C plus A. 100C
right.
plus 2.
We have to prove about 100B plus 10C plus A and 100C plus 10A plus B. And we have just now seen that 10 cube is 1 mod 37. So obviously we need 1,000 somehow. Multiply this by 10. Is this true?
Hmm.
Now we know when you do mod of this thing, we know 1,000 is 1 mod 37, right?
Hmm.
Do term by term mod of all of these. So this is what? This will be congruent to A mod 37. This will be 100B itself, right? We can't say anything.
Hmm.
This will be 10C itself mod 37.
Hmm.
Correct?
Hmm.
तो ये क्या नंबर बन रहा है mod में 37?
100B plus
10C plus A mod 37,
plus A mod 37.
which is what?
0 mod 37.
No, which is BCA.
BCA. BCA, हाँ.
BCA is 0 mod 30. उस साइड तो छुए भी नहीं.
हाँ.
Basically, all I have done is multiplied this number by 10 and seen that 1000A is congruent to A
Hmm.
when you do mod 37. And you leave the other two as it is, whatever it
Hmm.
is. So you're getting
Hmm.
100B plus 10C plus A mod 37, right?
Hmm.
Which is the number BCA.
Okay, yeah. Now we will multiply by 100, then we will get CEB.
We'll take the
CAB.
number BCA and multiply by 10
अच्छा हाँ
Yes.
वैसे भी कर सकते
because we
तो
have 100B plus 10C plus A multiply by 10
yeah,
to
so we
get
can get 100C plus 10A plus B is 0 mod 7, so CAB is 0 mod 7.
mod 37.
हाँ 37, sorry.
The point is, it is very easy. If you have a number that is divisible by some prime, the cyclic permutations of it seem to be also divisible by that, right?
Okay.
But not for any prime. It is only working because 10 cube was 1 mod 37, right?
अच्छा अगर 7 भी होता तो ये वर्क करता, 13 भी होता तो वर्क करता, क्योंकि 10 क्यूब इज 1 mod 7 और 1 mod 37.
Right. So what we can say is that if m and n are positive integers
Hmm.
and we have 10 power n is congruent to 1 mod m.
Hmm.
This m is our base 37 जैसा था.
Hmm.
Or mod 37 जो भी modulo. So now we can say that if you have a0, a1, an minus 1 are base 10 digits such that the number is this a0, a1, an or an minus 1 से start करते हैं. A0 is the last digit. This is the number capital N in base 10, right? And if this is divisible by m, then any permutation, cyclic ordering, if you change this, break this at the end, right? Any ordering an minus 2, an minus 3, a1, a0, an minus 1, right? Or bring this at the back now. Do you understand what I'm saying?
हाँ.
All of these numbers will also be divisible by m. That is the exact same proof that we have just now done for 37.
Just multiply 10, 10, 10.
Because this condition was happening, 10 power n is 1 mod m, and the power, when we are talking about base 10 digits, then everywhere you have powers of 10 only here, right? You have this here 10 power n minus 1, so you need to multiply by 10 to use this result. Correct? So that is like a generalization, but if you change the order, jumble up the number, then it won't work, obviously.
It has to be cyclic.
It has to be in the correct order. Okay, next class will be about divisibility criteria. We will look at some criteria of divisibility and look at some problems. And after that, we'll go to GCT and Bezot's lemma and things like that. Okay, I will share a problem set maybe by Monday. You can try that out over the coming week.
Okay, sir.
Okay, fine. That's all
Okay.
for now then.
Thank you, sir.
Thank you, sir.